Every year, HackTheBox conducts an exclusive Capture the Flag event for students. And this year, the event happened few days back. And the event is called University CTF. And now HackTheBox has released its track where they grabbed some of the interesting challenges and they added the challenges for the other HackTheBox users. Among these challenges, one challenge was so fascinating to me, and the challenge called the Magic Informer. Actually, the challenge was gained more attention during that CTF time itself, and it's a web exploitation challenge. In this video, I'm going to showcase how to exploit that web application, how we can pen test that web application and detects the vulnerabilities, and through that, by leveraging that vulnerability, we are going to gain the access to the underlying web server. And let's read the description given. The Magic Informer is the only bite-sized wizarding newspaper that brings the best magical news to you at your fingertips. Due to popular demand and bold headlines, we are often targeted by wizards and hackers alike. We need you to pen test our news portal and see if you can gain access to our server. So here is the description, and they mentioned like it's a news website, and people often target, like adversaries often target their newspaper site, and they are becoming a victim often to that attack. So they are asking us to pen test that specific website and find the flaws present in that. So that is our objective now, and we can start the instance here, and also there are some files to download. So these files can be useful for us to resolve this challenge. Now let me move that specific file to the current folder, the Magic Informer, and it's a zip file. Let me unzip that file. Before that, I need to verify the hash value of that file to ensure the authenticity of the file. And the hash is begins with 7090, ends with 1C3C. Begins with 7090, ends with 1C3C. That's why they gave the file hash value. And the zip password is HackTheBox. Let me unzip this file. Yeah, we got a bunch of files here. It's a folder actually, folder called Web Magic Informer, and we got a couple of folders and couple of files. So let me open all these files in a code editor, but before that, let's go to this website once. I access this website, and looks like it's a newspaper site as they described, and I'm just hovering through on the images. I'm just hovering the images, and I'm not getting any interesting links when I keep my cursor over these images. You can see the left bottom. It is nowhere. It redirects nowhere, and I'm not getting any interesting stuffs on this page. And but here, if I keep my cursor, if I hover my cursor on this specific image, you can see the left bottom. It is redirecting me to the another page, the page to called register, and that is something interesting. So let me open it in a new tab. Here is the page. I got a login page now, and a registration page now, where I can enter the username and password, and I can register myself to this site. And also I got another hyperlink here. When I keep the cursor over this, I can see it redirects me to the login page, and login page looks similar. So we got a couple of pages, login and register, fine. And yeah, rest of the things look static. I don't get any other thing from this page. But before I explore this sign up and login page, I wish to show the code. What are the files we got? What are the contents present in that file? So I'm opening it in the code editor. Yeah, uh, we have loaded every file present in that zipped archive. First, let me check this flag.txt. So they mentioned a fake flag for testing. So this is just a fake log. So nothing, I mean, this is not the actual one. And going to the Docker file, it looks pretty interesting because I can see a couple of interesting commands. First of all, let's see this one. From node, they are defining the alpine. Alpine is the Docker image, I guess. So looks like this web application is built on the Docker instance. So from this Docker file, we can understand. So the application is built on the Docker instance. So we are going to obtain the privilege of the Docker. We are going to access the Docker instance. So that is our ultimate access by leveraging the vulnerabilities. And let's see the second line. So it looks like it is adding some tools like curl, supervisor, GCC. It's a compiler, and curl SQLite. So it is adding the SQLite application into this Docker container. SQLite, it's a database application. So looks like it will be running a database as well. And they are making a directory /app. So they are making a directory called app on the root directory itself. And they are copying a file called flag.txt into the root directory. And they are also modifying the name to flag alone. They are removing the extension .txt. And the next thing is they are creating, they are actually trying to compile a binary file. Look at this. They are copying that read flag.c file from the config folder. If I go to the config folder, which is given here, I can see a file called read flag.c. And so this is the content of the read flag.c. Look at this code. It's a simple C program that tries to show the content of the specific flag file. So what they are doing, they are simply creating one C program that reads the flag for us. All right. Now in the next line, they are using the GCC compiler in order to compile this source code and making it as a binary. Also, they are modifying its privilege and removing the original source code from the path. All right. Look at the next line. So this is where they are adding the lines that is related to the web application. They are actually creating. This is already created directory. What they are doing, they are copying the entire challenge directory into the application directory. You can see this one. There is a folder called challenge, directory called challenge. So they are copying the entire challenge directory content into the application folder. So looks like this entire challenge, the files present in this challenge folder. Actually, this is the actual application. So that's what they are doing. And also the next line, set debug password. Looks like they are defining a passwords stuff. They are actually defining the password here, and they are copying the password into app debug.env. So this is where they are putting the debug password, and they are running one dependency, and eventually they are moving that supervisor d.conf file into HC directory. So let's see what is present in this supervisor.dconf. Supervisor d.conf. Here they are defining the service file. Looks like a service file. So this is the file where they define all the service parameter, the server to be running as which user, in which folder the server should be running. Those things and all they will be mentioning. Look at this. They verified, they mentioned the directory, that is the application directory, and the user is node. So this application is running as the user node, and the command is node space index.js. So this is the JavaScript. They are using the node application to run this JavaScript file, and they are mentioning it to auto start it, and also the restart they are mentioning, so it will happen automatically. And the log file dev null, actually they are flushing all the logs here. So that is the dev null directory denotes. And PID file, look at this. So this is where the process stuffs are stored. So they are simply defining the files, the relevant files and the user privilege, where the application is located, those things and all in this service file. So by referring this service file in the Docker file, they are trying to initiate the application. Look at the last line. This is where they are starting the Node.js application. They are calling the Node.js, the supervisor D binary and -c parameter, and they are calling hc to supervisor d.conf. So this is the conf file, and they are calling it with the supervisor D binary. So this is a Docker file that specifies some configuration, and eventually it tells to start the application, right? So the next thing is build docker.sh. There is a shell script. What it does, actually it builds that Docker image. So it builds the whole stuffs in a Docker image, and also it runs that specific Docker thing, the Docker application, and you can see the port has been mentioned. It is port 1337. So something is running on port 1337. You can just keep that like that in your mind. Now we have gone through this config folder and other 3 files. Let's get into this challenge folder, what is present here. And we got a bunch of files and folders here. So let me begin with this bottom, the package.json. Here it looks like the application name, version, and the JavaScript file name they mentioned. And apart from that, the dependent libraries version they have mentioned. Looks like this. So it's a Express framework based web application. So they mentioned the Express frameworks version, and you can see the Java web token library, and also they mentioned its version. And Nunjux, I am not positive what library it is, but look at the next one, SQLite. So this is the SQL DB related library. Yeah, this file contains these libraries and version information. And moving to the index.js, actually we have seen this index.js. This index.js file is referred in multiple places. So let's see what is present in this index.js. Looks like we got a few code blocks. Let's see this one. Import everything as .n from .n, and cookie parser, and path, express, nunjux. So we have already seen, these are the libraries being called in the packages.json file. So looks like this index.js is calling all the libraries mentioned there, and also it calls another index.js file from this route directory. Yeah, this route directory contains another index.js file, and it refers that file as well. And database.js, yeah, it refers that database.js file as well, which is present here. All right, now look at this line, .n.conf. It is referring the debug.n file. We have already seen in this Docker file, the debug.n file is containing the debug password. So this specific index.js file is also having this debug.nv reference. All right, and the next one, they are defining a variable with const, the phrase const, and they are calling the Express framework here. It looks like a function definition, and constant db, and they are actually calling the database, actual database here, admin.db. So looks like this is the database name. And scrolling down further, the Express framework is referring the JSON function and cookie parser function. And look at this one. There is a function called file upload, and you may see there is a size limitation. So it allows up to 2 MB files only. If the file is beyond 2 MB, then it won't accept. So looks like there is a file upload function. So when we log into that web application or somewhere, not necessarily in that login page, maybe it can be somewhere, there should be some file uploading page. All right, and the next one, Nunjux, it refers, it gets configure function, and I'm not positive what this code block is, but if I scroll down further, I can see some interesting stuffs like um, the express framework is getting the static function, and look at the last block. It connects to DB, and actually this one indicates the DB is running on the all interfaces and 1337, listening on port 1337. All right, but let's confirm this one. I'm not positive, but something is running on 1337 at this point. All right, and getting into the debug.yen file, look at this. There is a variable and a value, but I'm not sure. I mean, I don't think this is the value will be present in the actual application as well, since this is just this is given just to give you an idea about the application and what is the flaw in this application source code. You have to go through this source code and find the flaws present in this source code. So it will be helping you to compromise the web application. So that is why they gave this. But debug.nv, this is just to give you an idea how this file looks like, the format. All right. And getting into the views folder simply contains a bunch of HTML files. I can see the name, admin.html, dashboard.html, index.html, login.html, register.html, SMS settings, SQL prompt. All right. Now look at this page. We've already found register and login page, and looks like this views folder contains the HTML script of all the pages present in this web application. So we got 2 pages so far. We yet to find, exclude this index 1. We yet to find 1, 2, 3, 4 pages we have to find. But remaining 3 pages we've already got. The index page is nothing but this one, the newspaper home page. All right. And the next one is uploads. In uploads, I'm having a file called git keep, but it is empty. I'm not positive what is the purpose of this file. Moving to the next one, static. So it looks like this. This one is having 4 folders: CSS, images, JS, vendors. So let me get into the folder one by one. It contains some CSS files, some to beautify the application. So I'm ignoring this one and getting into the images. So it will be containing the images that are present in this web application. So we will see all the images involved in this application. I think most of the images we have found in the home page itself. All right. And the next one, look at this. JS is having a separate directory. It contains 5 JavaScript files. Let me go through the file one by one. auth.js first, and looks like this one is having some authentication logic. So the name itself denotes it should be containing some authentication logic. So like that, look at this code block. It is actually doing some username and the password comparison and giving the outcome based on the comparison results. And it posts some stuff, the username and password. Look at this, set timeout intent equal to login. Then it gives the dashboard page. When the user authenticates, looks like when the user authenticates, it gives the dashboard page. If the user failed to authenticate, it again gives the login page. So that's the logic there. All right. And going to the dashboard page, so this contains a lot of stuffs. I'm looking for some interesting code blocks. Enabling the word wrap will be making our reading process easier. A JavaScript file that builds this dashboard.js page, and form.js. Okay, and this one is having some functions. API enroll, a different path. So it is also having some API, application programming interface. All right. And sms.js. Getting into sms.js, the same API page, and all right. And sql.js. Do we have any DB credentials or some interesting info? Look at this one. This specific code block. They are posting some info to this specific path, debug SQL exec, and the header they are keeping the content type as JSON, and the another header as the SQL parameter and its value, password parameter, debug pass. So you know where to get the debug pass. Debug pass is present here in the debug.env file. So that is where, I mean, from where you have to fetch the debug pass, I guess. And here they are entering the SQL query command. All right. So looks like the same stuff given here, the same path, SQL query, and the password. All right. So let's move to the next one. This stuff is overwhelming. CSS files and font details, couple more JavaScript files, but we got bunch of contents in this file. Again, one more CSS font. Okay, nothing too curious here. All right, now we have 3 more folders left: helpers, middleware, and routes. I'll go through this routes index.js file eventually, but before that, let me check these helpers and middleware files. So under the helper directory, there is a file called jwthelper.js. JWT means JSON Web Token, and that is what the library they are importing. And also they are importing the crypto library. Look at this line. Actually, they are calling this crypto library and they are mentioning random bytes function, and they are defining the argument as 69 to string x. So what they are doing looks like they are creating some random bytes, some 69 bytes. I'm not positive, but they are creating some random bytes and they are converting it to x, I guess. Okay, so this one is one line, which is, which looks quite interesting. And also the same outcome, the outcome of this specific function used here. And you may see the algorithm. The algorithm is defined as HS256, and they are signing that Java Web Token with this specific stuff, I suppose. But let's see. I think the data is nothing but the data we are transferring, and the app secret is nothing but the cookie value, I guess. So looks like a cookie value, but we can confirm that. And the algorithm is HS256. All right. The next function is the decode function, where they are using JWT library in order to and its function to decode that Java Web Token. So yeah, looks an interesting code block. And moving to the next one, middleware. And in middleware, we got 3 middleware files like admin, auth, local. So let's go one by one. In the admin middleware file, they are referring the jwt helper.js file we just witnessed. And here looks like it does some cookie activity, as I said before. They are using some JWT cookies, Java Web Token cookies. Look at this one. Interesting stuff. So far we have seen the web page. Once a user authenticated, the web page redirects to the dashboard page. But here in admin middleware, you can see when the username is not equal to admin, it redirects that user to dashboard. So what if the user is admin? When the user is admin, where that user will be redirected instead of dashboard page? That one is a curious question, an interesting one. And the rest of the things, simply the logout functions. All right, moving to the next one, auth middleware. Even this one is referring that JWT helper, and here they are mentioning the same cookie stuff. When the web request is sent without this cookie value, looks like it sends us the message like authentication required. I think that's what I assume from this code block. Moving to the next one, the local middleware.js, and here you may see it's a loopback address and port 1337. The message is blocked this endpoint to whitelist the local host only. This endpoint is whitelisted to local host only. All right. So something is running on the local host. So that one we have to find. And the last but not least, under routes, I got another index.js file. Let's go through this file. Here in this file, we'll be getting a lot of interesting stuffs. Look at this, these library references. They are referring a path, and they are referring path and FS, a library called FS, and Axios, and they are also calling the Express framework the library, and they are calling the JWT helper.js file. So this is acting as a library file for this code, along with the auth middleware, admin middleware, and local middleware. The files, the JS files we found under the middleware directory. All right. Moving to the next, here they are defining a database, and simply the forward slash. Forward slash means the home page. So this is what they are referring, and it renders the index.html. So when someone reaches this IP address, simply along with the port, it gives this index.html page. When they tries with the register page, the register path, it gives the registration page, register.html. With the login, it gives login.html. And look at this one, API register. So there is another path. So let me try accessing that path. Why don't we try API register? Looks like it has the API. So it's an API. I mean, this is how the API is denoted in web server. So looks like the API is exist, and what is sent to this API? Looks like they are sending the username and password, and trying to get the username from the database here. Just for the comparison, when you enter the username and password here in the username in the login page, for example, if you enter test and test, then the value of username and the password you entered will be compared to the entries present in the database to confirm the actual username and password. So that is how the authentication works in web applications, most of the web applications. And let's see what else we've got. So once the user is authenticated, I mean, in the registration page, when you try to register with the name of the existing user, you will get this alert. If not, then you will receive the account registered successfully alert. And if something is gone wrong, this is the alert. So yeah, so this is just a registration code block. And for the API login, so this is how the code block would look like: authentication and the authentication failure. And look at this. So this one is so important, because if the username is admin, it redirects that user to admin page. There is a page called admin. We have seen only register and login so far, but what about admin? Let's try to access that page. It again redirects us to the index page. So it is not letting us access the admin page, but if you accessing it as an admin, then you'll be able to access it. All right, then we should find some way to access this admin page. Then moving to the next one, again login, the code block, the logic to redirect the pages. API upload once again. Looks like an upload functionality. No files were uploaded. Something went wrong. App uploads. All right, some file upload functionality. And the next one is, look at this code block, which is so interesting. They are getting the username and the login. Resume. What is resume? In resume, they are replacing the 2 dot and forward slash to, I mean, they are replacing this one with the empty string with nothing. So looks so interesting. Something is happening in this uploads page. All right, now again the admin page, and it is giving the admin.html. When admin user access this page, it gives the admin.html. And there is another page called SMS settings. But let me try accessing that SMS settings page. Once again, it redirects to the home page. All right, scrolling down further, there is another page, SQL-prompt. Same happens. And look at this, they are again posting something into this path. We have already seen this. Someone tried to post, a post logic to this specific path, and with SQL and password parameters. SQL is nothing but the SQL query. Password is nothing but the debug password from process.yen file. All right, some SQL query stuff are given here, and this one is looks like an important stuff, the important code block. We shall come to this code block later. Once we reviewed the web application, we had to review the web application. We were just going through, we've been just going through the code, the source code given in this challenge. All right, now we have gone through the source code completely. We got some idea about this register and login page. Let's get into this register page first and try to register something. I'm giving my name and password as please subscribe. I'm creating an account. It gives me the message of account created successfully. Now it automatically redirected me to the login page. Now I can enter my username and password. Please subscribe. User authenticated successfully. Look at this. Once we authenticated as the user other than admin, it redirected us to dashboard page. And look at this dashboard page, what we've got. We are in this dashboard page. It is asking us to enter some basic information like full name, phone number, date of birth, like that. And also it is asking us to upload a file. And here is the file upload thing. So I already said, so we got some upload logic in the source code. So we must be having some file upload place. So this is where we can upload some files. All right, so it is asking us to upload the resume. All right, now let me enter this stuff. Let me fill this. I'm just giving some random details. Now, before I'm giving save here, I'm about to intercept the web traffic and see what exactly happens while we post some data into the web application. So I'm clicking save here, and look at this. it is posting something to API enroll page. So whenever we are giving some details into the web application, it is posting into API enroll page. And also you may see there is a cookie value along with the details we have entered. And look at this cookie value. We've already seen this JWT code block. In challenge helpers, there is a file JWT helper. JWT means JSON Web Tokens, and it does, it did some operations, it did some JWT stuff to define, to craft the cookie value. So looks like the cookie is JWT cookie. We'll be able to decode this cookie if it is JWT. So in order to decrypt, in order to decode that, I'm using jwt.io website. So first of all, I need to turn off the interception. I'm trying jwt.io now. And here we can enter the JSON Web Tokens and decode that. Look at this JSON Web Token value. So I copied this JSON Web Token from the session we intercepted, and when I decode, I can see my username here. It is Perumal Jegan, and also it gives some random value, and here they define the algorithm. Algorithm is JWT. I think I need to enter it again. Algorithm is HS256. We have found this algorithm already in the code block in the JWT helper file, and here they define the algorithm, and that's what we have found here. So look at this. So this is the user ID. All right, now let's try to explore the upload functionality. So I'm creating a simple text file in my current directory, and let's try to upload that file into the web server. So I am echoing one simple content. This is test file. This is a test file, and I am echoing it to test.txt. All right, now we got test.txt file. Let's upload this txt file into the web application, resume.cv, and here I am choosing this. Going to stb web, the magic informer test.txt. All right, I chose the file and I'm uploading. Before I upload, I'm intercepting the web traffic. All right. Look at this. The Burp Suite intercepted that upload traffic. It posts the upload file. It posts the file into the API upload directory, and the cookie token, again, you can see the cookie token here. Let me decode this. Again, it gives the same user ID because I'm trying to upload the file from my user session, and you can see the content of the file. It is uploading the file here, and it's a text file. All right, now if I forward this, I can see the message resume file uploaded successfully. And look at this, a link is generated. A link is generated to read the uploaded file. So we uploaded the txt file, but looks like it converted that file into document. So let me keep my cursor over this. I'm not sure whether you can see at the left bottom, it is giving me a URL, and let me open that in a separate window. Looks like this URL, look this URL, it is actually read it into the download path, and also the query parameter is resume. When that resume parameter, it is actually referring that the file we have uploaded, but the format, the extension changed. All right, the file format changed. So this is the query resume parameter, and we have found this resume parameter here, I guess here in the routes file. Let me show that to you. Look at this. we found this resume value here. So what happens here, the URL format looks like it is susceptible to the uh, local file inclusion vulnerability, which means from this URL query parameter, we will be able to mention some path and some file name, and we'll be able to grab the contents of that file. So let me mention some file. I'm simply mentioning a typical etc passwd file to read the content of the passwd file, and I click enter. So let me forward this. Now I'm requesting to the etc password file content, and I'll forward this, but here I'm getting an error no such file or directory. All right, let me try backward slash instead of the forward slash. I try this. Now let me forward that too as well. We are getting a different error. Forbidden error. Forbidden. It is actually referring the files, the index.js file present within the send directory, and it is referring some other files. All right, now I'll tell you why the issue happening, why we are not able to read the content of the directory. etc password. Yeah, why we are not able to see? There is a reason, because the website cleverly applies some sanitization. Look at this logic. That's what I was trying to explain this line. Actually, it is replacing this specific uh, dot forward slash notation with the empty string, which means whenever you give the specific path traversal string like dot forward slash, then it will be replaced with the empty string, so it will be erased. This is how the website will probe now. This is how the website will parse now, because the dot slash replaced with the empty string. But now let me modify this one. I'll try to deceive this. I'm adding one more slash in front of etc passwd. Now when the web application replaces this dot forward slash with the empty string, one more forward slash will be left here before etc. So that will be denoting the root directory, the file system beginning, right? So let me try with this one and see it works or not. Still it is throwing some error. I'll do a little more modification here. I'm adding couple more dots. There are 4 dots and 2 forward slashes. 4 dots and 2 forward slashes. 2 more dots and 1 more forward slash. Now it looks good. Let me add 2 more dot and 1 more forward slash. Yeah, I'll explain what it does. Maybe I can create a new file here and zoom in a little bit. Now look at this. When when this code block replaces the dot forward slash with the empty string, what will happen? I'll show that here in a moment. So I'm replacing everything. Now look at this. It is doing some path traversal and referring the etc password file. Now I think we can try this one. So once that dot forward slash replaced, we will be referring the proper etc password file by doing some path traversal. Now let me try this. I need to forward this. Still I'm not getting. Maybe Yeah, looks fine. I'm forwarding it. Still, I'm getting the same error. Let me. I think I'm making some mistake here. Okay, look at this. Every time we try to access this HC pass WD with this modified path traversal notation, a file was downloaded and we were doing correct. So let me open one of these files. It is present in the downloads directory. So I'll move it to the current one. Moving it from the downloads directory, pass WD to the current directory, getting the pass WD, and look at this. We got the pass WD file contents. And yeah, I think it we successfully bypassed this security sanitization mechanism by simply adding two more additional dots and one forward slash. Yeah, so looks like here we found the local file inclusion vulnerability, and we can leverage this. The node user has the privilege to read because the web application is ran by the node user. So whatever the files the node user has the privilege, will be able to read those files through this local file inclusion. Why don't we try to read the flag file straight away? Root flag, because they removed the file extension. Now let me try to access this. No file downloaded, permission denied. We can see the error here. Looks like the node user is not having privilege to read this file. So we have to do few more stuffs to leverage this. All right. Now the next vulnerability I want to showcase is the cookie poisoning. So here we found every web request sent from the logged in user to the web server, it is actually adding a cookie. When we decode the cookie, we are getting the username. And here I'm simply modifying the username from my name to admin name. I'm simply modifying the name to admin here. So I modified it. Now let me copy this cookie value and manipulate the Burp Suite intercepted traffic. So I'm just going to replace the cookie value that I encoded with the admin name. Now let me refresh this page. Yeah, I need to enable this Burp Suite again. So I am simply reloading it. And here I got the cookie value. I'm replacing the cookie value. Let's see. Yeah, I'm forwarding it. I already forwarded, but okay, it does nothing. But let me try to access this admin page. Now I logged in, I try to access this admin page. I'm not modifying the cookie value right now. I'm simply forwarding. It is redirecting me to the dashboard page because I'm trying to access as Perumal Jegan. Now let me try to access the admin page once again by modifying the cookie value. I'll do it again and copy this encoded cookie value, the cookie value encoded with the admin username. And now I'm going to the intercepted traffic. Here I am simply replacing the cookie value and forwarding it. Yeah, look at this. We now grab the admin dashboard. So this is what the content of the admin page. We simply gained the admin interface, the admin dashboard, by simply doing the cookie poisoning. So far we have found two vulnerabilities, local file inclusion and cookie poisoning. Now let's see what we are getting here. We got a monitor page. I'm not able to click anything here in this page, but I can, when I keep my cursor on this dashboard, I'm simply seeing at the left bottom an admin page, and news editor again admin page, and news management. When I keep my cursor on add article, the same page it reloads. I mean, it loads into the same page, and update articles, it loads into the same page. But when I keep my cursor on this SMS gateway and SQL prompt, I can see it loads into the different page. Look at this SQL prompt and SQL SMS settings. And also we have seen this SQL setting, I mean SMS gateway and SQL settings here in this index file. Look at this SQL prompt page. It is showing the SQL prompt.html and SMS settings. It renders the SMS settings.html file. Gotcha. Now I access this SQL prompt file, and while I'm accessing, every time when you access a new page, you have to manipulate, you have to change the cookie value to the admin cookie. So I am copying that value again and going to Burp Suite page, and here I am modifying the cookie value and forwarding the request. I'm getting some garbages here. All right, now I got this SQL page, and look at this page, web SQL prompt. The password is debug pass. All right. So here we can enter the debug password, and we can able to run some commands like select all from enrollment. So this is the database query, SQL query. So we can query some stuffs here, but let's try to do that. But for that we need the debug password. We have already seen in this source code. The source code again helps here. In the Docker file we have seen the debug password is stored within the app debug.env file, but we don't know what is present inside this app debug.env. But we have the LFI vulnerability now. So by leveraging that LFI, we will be able to get the content of this debug.env file. Now I'm going to do that. So let me do that in a separate window. I am simply turning off the Burp Suite for a while, going to the login page again, logging in once again. Please subscribe. That's the password. Authenticated successfully. Now I try to upload a test file. I mean, I already uploaded a file, right? So I'm simply loading that one. So it downloaded that. So here is the page. I can add 4 dots and 2 forward slash, 4 dots and 2 forward slash in order to bypass that sanitization. 4 dots 2 forward slash, and now I am mentioning the file, the path. Here is the path, app debug.env. Now I'm entering. Hopefully, yeah, I downloaded the debug.env file now. Now I grabbed this file. So let me copy that file as well into the working directory. Move downloads debug.env to current directory. What is present within this debug.env? And here you may see the debug password, which is different from what we have seen in the source code. Yeah, now I am putting this debug password and I'm running some SQL query, but I don't know what is the table name. But in order to find the table name, we can simply refer the source code. In source code, we can see the database name. I mean, not the database, the table names and all. So let's try to get that. Select all from users. Select user from, okay. It does some queries like select all from enrollments like that. I mean, just for the sake of demonstration, I'm just using these users instead of enrollments, and I'm simply clicking enter. What happens? Okay, I simply need to intercept the traffic again, and I need to modify the cookie, right? So let me do that. Interception is on, and I'm entering here, and I got the traffic. So let me modify this cookie value. All right, I'm forwarding it. And now when I go to this page, look at this error. We got the error, blocked. This endpoint is whitelisted to localhost only. So looks like from this page, we cannot execute any SQL queries. But we got another page. The page is SMS gateway. We yet to explore this page. So let me go to this page. And once again, I need to modify the cookie value. It's a bit annoying, but you have to do this every time, since the web applications are, I mean, they cannot remember anything. It's a stateless. Yeah, look at this page. Now the page has been loaded. Yeah, here we can define the URL. In URL, I'm simply going to refer the localhost, because we can only query the database from, we can only query the database as localhost only, not from the other machines. Only from that same machine we'll be able to query the database. So that is what the limitation here. So I'm just trying to overcome that. We have already seen your database is running on localhost and a specific port. So let me get that port. I think it is 1337. I think I need to get that. In uploads, yeah, database, I guess. Not here. This one. Yeah, 1337 and 1337. All right. And the path. So we need to define a path to query. Which path we need to query? Look at this one. Debug SQL exec. So this path has been queried twice in this source code with the SQL parameters and the password, the debug password. We've already got the debug password. Now we also have the we also know the SQL command, and we know the path now. Now all we need to do is craft this query and try to get something from the database. And HTTP parameters. So we have to modify these parameters. As they mentioned here, the parameter should be SQL and password. And yeah, when you send the request to this, you have to ensure the SQL string and the password. The password, these are the two headers, SQL and password. So I'm simply giving password here first, password, and then SQL. I'm removing the third header, the third parameter. The password is nothing but the debug password we have already received. That is here. So let me get this one and paste it here. And SQL is something we already know. Select everything from users or enrollments, whatever. Users. So I just marked it as users. And the content type is application JSON. And here cookie we have to mention, right? So cookie, let me mention I'm going to HTTP history to find the previous requests, and here the cookie header. I'm bringing this cookie header and pasting it over here and replacing the cookie value. Done. Now it looks good. All I need to do is interception is on. Again, going to the intercept page. All right. Now I need to trigger this one. send test SMS. Yeah, and I need to modify this JSON web token. Yeah, let me modify this, and I'm forwarding this request. Now it is done, it is forwarded, and look at this, the result. Address is unreachable. Looks like a promising result. I nearly got this. Select all from users. Address is unreachable. So that is the error. So are we making any issue? I mean, are we making any mistake? Yeah, look at this. I forgot to do a small modification here. It is just trying to access with HTTP over SSL, but it is HTTP. So I'm removing yes, I'm simply trying HTTP on this address. Now everything looks fine. Intercept is on. JSON web token copied, and going to this and modifying the cookie value, forwarding it. Now let me see this page. Now let me query the different stuff. Instead of this, enrollments, the same stuff I'm querying. Enrollments. I think that is the proper one. Now, once again, I'm sending the test SMS. Modifying the cookie value, forwarding the request. Going to this page. It renders an HTML page. All right. Here I made a blunder mistake. Just now I am realizing it. I forgot to add the semicolon at the end of the SQL statement, because this is very mandatory. Otherwise, you'd be getting the errors only. All right, I got it now. The password is correct, everything is correct, but the cookie, here you can see the cookie :session equal, that actually repeated. That is where the mistake was. All right, now I corrected that mistake, sending it once again, going to Java Web Token, copying it, replacing the JWT, and here I am forwarding the request. Now I should be getting some fruitful info. No, not yet. Why? So what the heck happens? Cookie. I'm not even using the proper cookie now. So this is the cookie I'm supposed to use, but I'm using the wrong one. Then how would I get the error? I mean, how would I get the outcome? So this is the proper cookie. Now I replaced it, and the debug pass, the query, semicolon, cookie session, only once it entered. Now it looks fine. I think it should be working now. Let me try this. Copying this token once again, going to the interceptor page, replacing the cookie value. Now I forwarded it, going to this page. Yeah, look at this. We got the outcome from the SQL page, and I'm just putting it here in a separate sheet. We got the user and the password hash. We got the admin hash, but this is not what we wanted. We need to get the access of the underlying machine, which means we need to get the access to read some sensitive files in the Docker instance. But for that, there is another way. Here in the code block itself, they gave, if you look at the code block carefully, you can detect the code execution possibilities. Looks like this specific code block is having some code exploit stuff. We'll be able to exploit some commands, I guess. With this, you can understand there is a function exec sync and the command execution. Look at this. So this is the command. They are actually referring the SQLite 3 CSV file admin DB. They are actually grabbing this admin DB and executing whatever the query we are sending. So this is the variable, and here they are allowing us to execute the command, looks like, but I'm not positive whether can be done, but let's try. First of all, I need to find a way to execute the command in the SQLite. Execute system commands in SQLite database. How to execute shell command in SQLite query. Look at this. The Stack Overflow is always an awesome resource. So here they are mentioning a word .shell, subsequently the command to execute. So why don't we try this instead of this typical database query? We can replace it with this one. Now I'm copying the same stuff here, so it should be replying hi there message to us. So let's try that. I'm going to this magical informer page again, and here I'm replacing this SQL query with .shell echo hi there. So I'll be getting the message hi there alone. So if I get this, then you can understand like there is a code execution. All right, now let me intercept this once again. I'm sending the test SMS here. I'm going to, yeah, here is the one that we just sent. I'm copying the cookie value and replacing it here. All right, now I'm forwarding it. Let's go to this page. And we got some meaningless stuff. .shell echo this one. Okay, instead of this, let me try to execute some other command. I'm executing who am I after .shell, and let me try this. Send SMS. Look at this. There is a code execution. We executed a command who am I, and it gave us the outcome node. We know the web application is being ran by the user node. From this debug, from this Docker file itself, we understood that the user node is running the web application. Now we got the code execution. All we need to do is try reading the flag file, and let's try to do that. So let me use the cat first of all to read this file, and going there, replacing the cookie, and the output is still nothing. When I try to read this flag file, I don't get anything. So let me try to find the file privilege, ls-la. So it will list all the files present in the root directory, root home directory. Sending test SMS, going once again to the interceptor and replacing the cookie value, forwarding it, moving again to the browser, and output is total 0. It shows nothing in root directory. So looks like that file, the flag file, is not even having not even allowing us to read, see its presence. So what I can do, I can probably use another thing here. I don't know if you remember or not. Here they are actually defined a C file, C program to read the flag file content. And that flag file content, you can see this read file.flag. It actually reads the content of the flag file. So let's try to execute that. I think we can able to execute that file. The file name is read flag, that is present on the root directory itself. Read flag. So let's see the privilege of that. First of all, I'm trying to read all the files present in the root directory, and I'm grepping the specific file, and the file is read flag. Okay, now at this point I can modify the Java Web Tokens. Forwarding it again. Let's see here. Look at this privilege. Any user can execute this file, this read flag file. So our next step is to execute this read flag file. So let me do that. I can go to the root directory, and then I can execute the read flag file. So this is the command I am executing. All right, now let me intercept it for one last time. Replacing the cookie for the last time, forwarding it, and here we got the flag. So this is what I wanted to showcase. Here in this web application, we have found 4 critical vulnerabilities. The first vulnerability we found in the file upload. I mean, when we seen the uploaded file, we found the parameter resume, and there we found the local file inclusion vulnerability, and there was some sanitization technique. By looking at the source code, we managed to bypass that sanitization tactic. So where is the tactic to sanitize the local file inclusion attempt? I think it contained in this routes file only. Yeah, here it is. So this is the sanitization logic. We bypassed it, and we were able to read the debug.env file, and by decoding this Java web token, JSON web token, we were able to see the user, and we manipulated the user and again encoded this token, and we intercepted the traffic, and we have switched that cookie value. Then we obtained the admin privilege. We logged in, we accessed this page as an admin by simply doing some cookie poisoning. That is the second vulnerability. And the third one was, we were not able to execute any SQL command with this SQL prompt page. Instead, we used the SMS gateway to execute the SQL command on the on this host itself. So where we found only the local host can do the SQL command query. So what we did, we managed to change the IP address to the loopback address here in this SMS gateway URL bar, and through this we'll be able to, we were able to query the database and got some sensitive information. So this is the vulnerability called server-side request forgery. So we actually manipulated the server to send request to the database on behalf of us. So that is all about SSRF, and we managed to leverage that as well and got some sensitive info from the database. And the final stuff was the code execution. We have found the code execution in this code block. I suspect this is the command, this is the line which causes the code execution, and these 2 lines, I guess, causes the code execution. And I actually googled about executing the system commands from the SQLite prompt, and added this .shell string before the command and executed the command, so that I was able to execute the command and read the sensitive file contents as the user node. So these are the 4 vulnerabilities I wanted to showcase. So the one web application, 4 different vulnerabilities. So that is the fascinating thing about this specific challenge I came across. So yeah, this is what I wanted to showcase. Hope you really liked this, the Magic Informer challenge. If you really did, don't hesitate to subscribe my channel, and also you can hit the bell icon to get notified whenever I am posting a video. And you can also like this video. If you have any other opinion, put it in the comment section, and also you can share this video among your friends. um, I'll see you all next time with another useful content. Until then, I'm signing off. Cheers and bye. Thank you.